Okay, welcome back for the basic programming of the GDA. So the next grammar I want to understand the matrix. How do you matrix? How do you matrix? So this is the example of the program using the matrix. So this means I'm sorry, there's a small version. It means the name of this program is matrix. And then I'm not sure about this command stands for dimension and symbol. I'm not so sure, but anyway, this is the declarations of some parameters. Then name of parameter can be this means the parameter of our variable name AA is the matrix of Sendo and column 3. This means this is a declaration of the variable. That variable is size of Sendo and column 3. And this is the for next group for change I equal 1 to 10, j equal 1 to 3. And input the value at the cells ij to variable matrix variables j, ij. So you can give all values to this matrix values. And this is the special command for VBA, just to change cells 1 to cells 10. Select these ranges and you clear content there. So just clear content there. So you don't need to necessarily you don't need to use this command because yeah, it is also useful if you remember this command. And then changing the from I equal 1 to 10 and z equal 1 to 3. And also write the contents of these parameters ij to set ji. It means row and the column is reversed. And the next day and next time. So this is the command of the matrix. So now you already have these numbers. So using these numbers, you can create these numbers. Just copy and paste here. And then this is error. This means error. So these are comments. So you can just delete this comment, or you can also declare these are comments. Comment means this is the comment. So just if you write apostrophe before some comment, it means comment. So there's no error here. You can these dimensions, or you can change these parts for comment. I'm afraid I need this Japanese characters here, so in your case, you should maybe define characters. Anyway, change or delete this comment. So change here and carry out the macro matrix. You can find here and carry out the matrix here. And now you can find size of row 3 and column of row 10 here. So this, I don't know why, oh, there are no clear content command here. I don't know why. I'm sorry, there is no clear content, so clear conscience here, and try to use the same number of the data. Here is not close. Now, no one can be reversed. So these are how to use the variable of matrix variable. Maybe I also need to explain how to use the matrix variables in the real computer simulation, real simulation of the environmental method solution. And one more grammar you want to understand is the type of data and also how to use functions. So this is example of the type integer. Integer is the k as integer. It means the variable k is the type of integer. And in this, yeah, I don't use grammar, but okay. So in this command, so if k is integer and for real values, so random for cells I1 is equal to k because k is integer and even if it is real values. So for example, real value in cells I1 is 1.123, and in this case, k value is k values just only one integer one is linked to k. So these are the examples, and another example is the integer, and this is the round also round the values. To show each real number subtracted by round down of each value, we can find the numbers to be changed at all. So here, by this command, only round of values the value of cells I1 is equal to k. But here, using the integer functions, rounding values of cells I1 is equal to k. Maybe, yeah, it is more understandable to see the examples. Let's input the real values here. Yeah, just Nokia and 10 real values. Any value is okay. The value is okay. And copy this command to editor. And this is command, so change it to command. And carry out the macros data type. So now we can see here 0.4 because this command is you write the result of the difference between the number in cells I1 and the random values of cells I1. So in case of 6.4, the random value is 6, so the result is 0.4. In case of 9.6, So round of value is 10. So the result is minus 0.4, just like this. And also you can use the, the integers, the integer function, for example. Just like this. And in case of integer functions, the result is changed. Just like this. Just only cutoff value. Integer functions means please input the just cutoff values to integers. It's inserted to the variable k. So in this case, 9.4 result of the integer function is 9. So the difference between 9.6 and 9, the result is 0.6. So the result is different. Anyway, these are how to use the functions. Already some of the function is defined, just like the exponent, logarithm, or sine, cosine, tangent, or R&D the random numbers. You can increase the any random numbers up to 0 and 1. So these are very common functions you will use. And there are another type of data. So example is the ghost integer or single. Okay, integer is the integer type of integer is integer. Integer is integer, but it must be greater than minus 32,768 biggest value is 32,677. So if you want to use bigger integers, you need to use the type of long. So for example, if you want to iterate 1 million times, you should use the long variable, not the integer variable. So default of the parameter is I think maybe integer. So if you want to use bigger integer values, you should use the type of long. And the maximum value of the long is 2 billions. 2 billion or something. So this is the biggest value you can use in Excel. And the single is the real values. Single is the direct values. But precision, maximum precision of this value is just I think maybe 5 or 6 digits. So if you want to calculate the difference between 1.00001 and 1.00002, they cannot understand the difference because in the case of single values, just the precise value is only 5 or 6 digits. So if you want to calculate more precisely, you should use the W. So I think maybe actually in practical case, for scientific calculations, I think you should always use W. Maybe there is very rare case that you can use the single values, single real values. I think in the scientific calculation, always you should use the W values. And another type of the variable is string. If we want to write the character, if we want to say the kind of characters to some variables. So these are the type of the variables. Okay, so I think these are the necessary grammars to understand the computer simulations. And the next one is the function of matrix. So we will also support the function of the matrix itself. Add of matrix or subtract of matrix or multiply of matrix. But yeah, now today I don't use the these grammars. So I want to skip here. And also graph. So also VBA can provide a graph, and you, for example, you can record the drawing the graph, and you can just copy and paste that macro. For example, just okay. Anyway, this is the x-axis and y-axis, and now you draw the graph and stop the recorder of the macro. Now you stop the recorder macro, and my editor, please check the macro queue. Now you record this rating, and you can find this is the macro to draw the graph. So you can copy this part to your program. Then, for example, you can automatically draw the result of the calculation. So not only calculations, but also you can show the result of the calculations by figures automatically. It is very easy. It's very easy. Okay, so these are the necessary grammars to understand the simulation today. And now I move to the explanations of the simulation of the movement of the environmental pollution. So it's okay, so now first I explain the theory of the computer simulations of the environmental pollutant, and then I hope you can use the macro or you can use the program by yourself and changing the sum of the parameters. Okay, now simulation of the movement of chemicals in the environment. This is the typical model of the movement of environmental pollutant. Environmental movement model of the chemicals including people. Now, I'm sorry, my example is not so good. My example already includes the human beings in the models. But usually, environmental models don't include the human beings. And they just calculate the concentration of pollutant in water or soil or vegetables or some kind of air, sometimes air. And from those results, they calculate the exposure to human beings, considering the amount of the air they breathe and the amount of food they eat, or amount of water they drink. But in these examples, only human being is included in the model. So not so different, but I thought common, I thought uncommon. Okay. Okay. Anyway, here I just show you the simplest model to show how we can use Excel VBA for the simulation of the movement of chemical in the environment. So let's assume the environment has just four compartments: water, soil, vegetable, human. Four compartments, or we can say four media. And let's assume this water is water lake, and soil around the lake. The soil means soil around the lake. Vegetable means vegetable growing on the soil, on this soil, and for target human beings. Let's also assume that they eat 100 grams of the vegetable and 0.1 gram of soil, just like the plants. So, soil particles, and drink 2 liters of lake water every day. Let's assume. So now, using these assumptions, you can calculate the exposures at the same time. Okay, now there are parameters to express the movement of the chemicals in the environment, as shown with the figures. So T1 And Q1, PI is the input of the chemical to compartment I. So it means some of the pollutant is input to take waters from maybe industry or some, and also they flow out at the level, at the speed of the flow rate of the Q1. Of course, maybe the water is going out of the river, and those rivers contain the also contaminant. So QI is the output of the chemical from the, in this case, compartment one. It means output from the lake water. And not special input to other media or other compartment. Only human beings. This is the expression rate of the human beings. So pollutant enter the human body, excluded to the rate of the Q4. So anyway, these are important attributes from the compartment. And the AIJ, this is the flow of chemical from compartment I to Z. So A12 means flow rate of the movement of the pollutant from lake water to soil around the lake. And in case of parameter A21, it means flow rate of the pollutant from soil around the lake to the soil water. If soil particles just enter the lake waters, in some cases, pollutant moves from soil to waters. So A21 is the flow rate of those transportations, those movements. And S23 from soil to vegetables. So it means vegetable absorb the pollutant in soil. So this is the flow rate of the pollutant from soil to vegetables. There's no, now we don't assume there are some of the movement of pollutant from vegetable to soil. All vegetable is maybe taken out and sold to somewhere else, eaten by people. If vegetables remain there for 1 year, some of the pollutant in vegetables also go back to the soil. But in this case, we don't assume. And human beings, people just eat vegetables. So there are the also product from vegetable to the human. And people just eat soil, from soil to the human. This is the stage before. And people drink just water. This is product is A14. So these variables, Ij means the movement of pollutant or flow of the chemical from compartment I to compartment Z. So if you assume these parameters, so the model can be generally expressed by these equations, this differential equation. Actually, this is the simultaneous differential equation. So this means VI is the volume or mass of the compartment I. So VICI means the total amount of pollutant in compartment I. So if the example, the volume of lake water is 1,000 cubic meters. So and the concentration of the pollutant is example, the 1 gram per cubic meter. So total amount of pollutant in lake water is VI and CI. So this is the total amount of the pollutant in each compartment. In case of soil, so you need to assume the total volume of the soil around the lake waters. And also vegetables, and also even human beings. You need to assume the weight of the people, or number of people, and the total amount of pollutant in human body is the weight times the concentration of pollutant in human body. So this is the total anyway, this is total amount of the pollutant in compartment I. And this amount is this is the change in unit time. So this is the differentiation. The VRCI over dp differentiation of total amount of pollutant in compartment I. Change of the unit time, change in unit time, change in unit time. So change in unit time is expressed by input values and the output values. But the unit time, input to compartment is the PI. This is the amount in input time. So in this case, in the case of orders, this is minus means from input from compartment I to compartment 2, pollutant move out at the rate of A12. And AJI means from compartment 2 to 1, pollutant input in the input time. So this is the input to all input to compartment I. This is the all output from compartment I. So the change of total amount in compartment I is expressed by total amount of the pollutant which move out from compartment I and the total amount of pollutant which come into the compartment I and into the value to compartment I and the minus of the values from compartment I. So it is the change of the total amount of pollutant in compartment I in unit time. So this is the meaning of this differential equations. And you can make these equations for each compartment. So in this case, 4 differential equations can be established to express the element of pollutant in these compartments. So in this case, so actually, in compartment 1, it means the recorders, the change of total amount of pollutant in recorder is the first equation. The change in unit time of total amount of pollutant plus A21 minus A14. It is almost negligible compared to the total volume of the recorders. Just the volume of the drinking water is very small. So it is sometimes it can be negligible. And anyway, and also P1, input value to P1 and output value to P1. The second equation is for the compartment of soil. So the total amount of pollutant in soil is in unit time, pollutant come from water to soil at the rate of 8.2, but go back to water at the rate of 8.1. And also, pollutant is absorbed to vegetables at the rate of 8 to 3. And also, people just eat small amounts of soil at the rate of 8 to 4. This value is always sometimes negligible for the difference of, for the change of the total amount of the pollutant in soil. But in this case, we also consider this. For compartment vegetables, input value is at A23, output is A34. So this is the change of the total amount of pollutant in vegetables. And in case of human body, human beings, from water, pollutant comes to human body at the rate of A14, and from soil A24, from vegetable A34. And excretion ratio of the pollutant is the Q4. This is the expression to express the change of the total amount of pollutant in human body. So the problem is, so this equation is simple. So even analytically, we can solve this equation. But the problem is how we can estimate these parameters in the environment. So this is the work of engineers, or sometimes modeling is called one art. So you need a sense of art to make these models and to estimate these parameters. For example, now assume we need the volume of each compartment. Let's assume volume is 1,000 cubic meters. So total amount of volume of water in lake is about 1,000. And assume it is 100,000 kilograms. So maybe um, this soil is just around the lake, and considering the area of the lake, and considering the soil depth, which is affected by the lake waters, let's assume about 10 centimeters or something. And from those calculations, we can get the total soil volume or total soil weight, which has relation to the movement of pollutant is about 100,000 kilograms. It is case by case, of course, and it is also you need some sense, or you need some you need to review some papers. How many centimeters is enough to construct something. And let's assume V3 is 100 kilograms. Now, vegetables which is growing in this soil, on this soil is 100 kilograms. And the V4 is the all weight of the all people living here, living in this area. So weight of one person is 50 kilograms, and the 100% is living there. So this is the total amount of weight of human body. T1 is input of heavy metal to water. We assume it is 1,000 milligram, it is 1 gram per day. This value is obtained from the actual measurement of the disposal of the factory, discharge water of the factory, and the Q1 is also estimated. Output of heavy metals from the lake water is C1 is the concentration of river water, lake water, and the times 10 cubic meter per day. This is the daily outflow from this lake. So it means we have the total mixing here, total mixing with the lake. So, and the river water come in at the rate of 10 cubic meter per day, and will go out at the rate of 10 cubic meter per day. So then daily outflow from this lake is 10 cubic meter per day, and the daily output of heavy metal is computation of heavy metals in the lake or pollutant and the times the flow rate. This is the speed of output or flow rate of output of pollutant or heavy metal in this case. And Q4 is the expression rate of the heavy metal in human body. So now we just assume concentrations of heavy metals in human body times V4 the total amount of the human body. So this means total amount of the pollutant in human body. So on 0.01 per day, it means 1% of pollutant in human body is excluded every day. So this is the how to assume these numbers, two parameters. So of course these numbers can be changed and considering the real conditions. You can use the actual numbers, and you can calculate these or estimate. You can estimate these numbers from the data you can use or from the consideration of the actual conditions. So many people say you need some kind of sense. You need some kind of sense of art for the modeling or for the estimation of the parameters. Anyway, using these assumptions, you can from now you can assume the value of parameters. I don't know why some kind of malfunction here. Sorry. Okay. And the expression of the value of each quantity and parameters. So now we need to estimate the flow rate from compression type to compression state. We can estimate it. So A12, it means movement of pollutant from the lake of water to soil. So we can estimate it. C1 is the concentration of the pollutant or concentration of elementals in lake waters. And 10 cubic meter per day. This means this 10 cubic meter per day is the average irrigation of lake water. From the survey the actual conditions and review to the farmers. Now you know about 10 cubic meter used for irrigation. So in that case, movement of pollutant or movement of minerals in water, in lake water, move to soil at the rate of concentration in water times irrigation rate. So this is the how to estimate the this parameter A12. A21, you can also estimate it using the concentration of the minerals in soil. C2 milligram per kilogram is this concentration of chemicals in soil, and times 1 kilogram per day. 1 kilogram per day is the average erosion rate from soil to lake. So you can also make some investigations or measuring the situations of the movement of soil particles. Soil particles from the land surrounding the lake to the lake waters. So, on considering the area and the average erosion ratio, usually, for example, 1 centimeter of soil is eroded to the surface waters in 1 year. So, using those average values, you can also estimate the approximate values of the movement of the pollutant from soil to waters. That is how to document the value of A21. Value of A23. A23 is the from soil to vegetables. So you can estimate it from the absorption ratio or absorption rate of the pollutant from soil to vegetables. So, for example, C2 milligram per kilogram, which is the concentration of pollutant or pollutants in soil, times 1,000 kilograms. 1,000 kilogram is the quantity of soil from which the chemical is absorbed by vegetables. Anyway, it's the total amount of pollutant in soil. And 0.01 per day. It means 1% per day. So it means absorption ratio, absorption rate of the heavy metals by vegetable is 1% per day. It means total amount of heavy metals in soil, 1% of total amount of heavy metals in soil move to or absorbed to the vegetables every day. These numbers can be also estimated using the experiment growing the vegetables, and you can monitor the how the concentration of the metals in vegetables changes. So from this result, you can estimate the this absorption rate. So for modeling, also this parameter is necessary. Sometimes we by ourselves carry out the experiment using some vegetables, but in another case, you can also review some papers and maybe you can find this absorption rate from other papers. And S4 is from vegetable to human beings. It is easy. You can estimate it from the total amount of potato which is eaten by people. So C3 is the concentration of the metals and vegetables. 0.1 kilogram per day is the which one person eat the vegetables, and 100 is the number of people living there. And A24 is the total amount of the soils from soil to human beings. So concentration in soil times how many grams people eat or people intake under the 100%. So this is the total amount of the movement of water from soil to human beings. And A14 is the also from water to human. So concentration in the water times average volume of the drinking water times 100%. This is the total amount of the movement of fluid from compartment 1 to compartment 4. So then you can use these values for the equations there. So you can substitute these values to the equations, and finally you can get to these four simultaneous differential equations. And now what you need to do is just solving this simultaneous differential equations. Of course, some people can solve this analytically, but recently computer simulation is much easier. So after getting the simultaneous differential equations, now and we change it to the numerical differential equations. From the differential equation to the difference equations. I mean, the differentiations of C1 is instead of the differential of C1, we use these equations. C1T plus dt is the C1T means the concentration at the compartment 1 at the time t. And C1T plus dt means the concentration of the pollutant in compartment 1 at the time t plus delta t. Delta t is a very small value. For example, just one day, if you simulate the several years, one day is a very small, very short time. So, for example, one day, and divided by dt. So this can be the approximate value of the differentiation of the C1. So also other things. So right side is the same, but the left side differentiation part is changed to these approximations, numerical approximations. So the two C points the substituted to these approximations. And of course, about dt, it is better. We should use the shorter time, the better for the precisions of the simulations. But if we use the very small value of dt, it means for long-term simulations, you need the very long simulation time. So it depends. Anyway, now multiply dt of multiply both sides by dt, and just transport not the differential equations, just simple equations, simple linear equations. So from these equations, multiply both sides is multiplied by dt, and just move the C1T value to the right side. So now we can get this case. Also C2 value, C2 C2 value. So this means if you know the concentration of each compartment at time t, you can estimate the concentration of time t plus ft. Now you can calculate. Then now you know the concentration of each compartment at time t plus delta t and change it to the value of time t. Then you can newly more dt progress values. I mean, if you use t plus dt values for these values, you can calculate t plus 2 delta t values. And if you insert the value of the C1 value at the time of the t plus 2 delta t values from these equations, you can calculate the t plus 3 delta t values. So just like it, so you can calculate the any time. You can calculate the concentration at any time. This is the numerical simulations. And this is the one with the simplest method of the computer simulation. Simplest method of the computer simulation. We call it the forward differentiation, or forward method of the differentiation. There is another method of the backward differential equations or central differential equations. But today I just explain the most simplest method of the differentiations. Well, I should say approximations, numerical approximations. So the forward approximation is the most simple. In case of forward approximations of the differentiation, we use just like this difference. So dC4 over dt is approximated by this difference over dt. In case of backward differentiations, this value is approximated by C4t minus C4t minus delta t. That's the backward differentiations. So in that case, the equation is a little more complex. So if the forward differentiation is enough for your purpose, yeah, it is much better because it is very simple. Now, anyway, now you got these equations, and to solve these equations, the VBA or Excel is very good at these calculations. The next one is the this is just an expression of the using matrix. So these equations, these simultaneous linear equations, is expressed by the matrix equations, just like this. Ct plus delta. This is a vector. This is the vector of these vectors. Ct plus delta t equal A times Ct plus p. And in this case, Ct is the vector of Ct, and p is the just input values. Now, p is represented only here, only at the first equations. So only first, only first row, they have the p, vector p and the values. And A is the matrix, parameter matrix or coefficient, sometimes coefficient matrix. So each term of the matrix is the example. So anyway, this matrix equation is just expressed with these equations. So C1t plus delta t is the C1t times 1 minus 0.01 delta t plus C2t times 0.01 delta t. And and also there will be minus values here. About C1T, minus 0.01, T, and minus 0.02, T. So and these values is mixed and arranged and to express. So 1 minus 0.01 delta T minus 0.01 delta T minus 0.0002 delta T is the 1 minus 0.0202 delta T. This is the how to calculate the value of each term of the matrix. And the first equation has the only C2 value, not C3 value, but C4 values. There is no C3 value, C4 value, only C2 values. So for C2 value, 0.001 delta T. So in the matrix equations, there is only one term here, 0.001 delta T. There are no terms for the C3 and C4 at the first equation. Also, second equations, third equations, and fourth equations. We can get these equations. This is the just matrix expressions for these simultaneous linear equations. So if we are not so sure about the matrix equations, you can directly use these equations. It is enough to use these equations. Okay, so now these are the equations you need to solve. So this can be calculated easily by XVBA, and if we set the initial conditions, we need to set up the initial conditions because we can calculate the value of concentration of each compartment at time t by delta t. But to calculate those values, we need to know the first concentration of each compartment. It means at the time is zero. At the initial conditions. If we know the initial condition of each compartment, so we can calculate we can calculate the concentration at any time. And delta T must be small enough for getting the effective solution. And the concentration or mass of each compartment must be effective at any time step in any condition. Yeah. Delta T should be small, but sometimes to save the computer time, so we use the rather big value for delta T. But we need to fulfill these conditions. So the mass of each compartment must be positive at each time step. Yeah, I will explain later. And you can use macro simulations of the power simulation program itself for this calculation. So these are the examples you can make for the environmental simulation. Okay, now let's move to the Excel. If you already download the file of the simulation program, don't forget to activate the macro. If you are asked, you should use the macro or not, so please make it active. Okay, so now we just explained these conditions of the equations, and this is the matrix, or this is just expression of the simultaneous linear equations. C1 t percent t equals minus 0.0202 C1 plus 0.001 C2 plus 1 T1 1 at one time. So these are the conditions of the equations that we set up. And okay, so just look at the macros. Oh, sorry. Okay. Now look at simulations. Now we can see the also other macros in which one in other methods we made that we made before, but now we just use the simulations here. And now you can see the program of the simulations. So this is the okay now this is the name of the program simulation, the name of this program. And this is a declaration of the type of the variables. MA is this means matrix bracket. Name of variable and bracket means this means matrix. This variable is the matrix. And the type is double. Real values, very long real values, double. And the G bracket as W's, CT bracket as W's. So these are just a declaration of the vectors and matrix. And DT is also W's, and then the bracket is the matrix of the W's. And we are also W's. So please, for scientific calculation, please use the W for real values. Not going to use the real, but use the W. And N is equal to 4. This is the number of compartments. And D equals 0.1. This is the time dispersion fluids, geometry values. Now here maybe unity day. So 0.1 means delta T value is 0.1 day. And the big image. This means now here we just declare this variable is matrix or vectors. And here we declare again or these declarations the size of each matrix and vectors. So MA size of MA is the row is MS and the column is MS. The size of vector is MS and the size of the vector is MS or matrix is MS. We declare again the size of the matrix for vectors here. And from now we did each value of parameters of A. Here we did the parameters here. These parameters is given here or given here. So this parameter is given here. And now you read the parameters of matrix A to the variable matrix variables in A. And then PI values also PI values is input from here. We read the value of PI values from here. And next, just okay. Now we need the value of matrix A and vector P, and now we are going to now we try to calculate these values. Sorry, it's not enough for the question. So now we want to calculate the matrix A and vector CP. So at the first value of CP is the initial conditions. Initial condition of the or initial concentration of the heavy metals in each compartment. That the CP equals 0 values. And the matrix A is now already into the variables in programs. And now we want to calculate the multiplications of the matrix A and matrix C for calculation of these equations. So the calculation, how to calculate this matrix is expressed by these parts. First, we just my we want to say the result of the multiplication of the matrix MA and P, MA and CP. We want to save it to the MY. So first we declare all part of CI equals 0 and just only the center line the number 1. It means MY is the unique matrix. And CPI, so we input the initial values, initial conditions, initial value of each compartment. It is here. So initial value at each compartment, initial concentration is 0. So no pollutant in each compartment. And then calculate these equations. I'm afraid I don't have enough time, so I don't explain it so in detail. But now here we are calculating these calculations. Vector A times vector C plus B. We calculate these parts by these calculations. And finally, we can get the result of the calculation at the CT values. So CTD VA is the multiplications of A times CT, and those result of the calculation is into the CTD values. And the new concentration, I mean, delta T progressive concentration value is obtained at the CT here. And here we just output the result of the calculation. Here we output the time, how elapsed time, and here is the each value of each compartment. So the result is just like this. So the result is just like this. So time, this is the elapsed time, and the was also based about 2 months. So now I just okay. Now yes, the result here. Okay, and the macros. Carry out the macros. So delta T value is 0.1, but I just want to output the just every 100. So I mean, so every 10 days I output the result of the calculation, so I output the concentration of each compartment. So here iteration from 1 to 100. So iterations 100 times. It means delta T times 100 iterations or elapsed time part. It means 10 days part here. So after 10 days part, we output the result of the calculation. So in this under 100, so it means every 10 days we output one result. and iterate one at a time. It means finally we calculate 1,000 days, 1,000 days. So anyway, the result is we carry out the simulation here. And we go to the result of the calculations. And now you can draw the graph, graph of the change of the concentration at each compartment, just like this one. So x-axis is the reaction time, y-axis is the concentration of the each compartment. So now you know how concentration changes depending on time. The initial condition is 0 for all compartment and just input the value and assume that values. And you can change these simulations easily. You can change these programs easily. For example, if you change the, for example, the, okay, simplest change is the, okay, let's change the input value, for example, not only waters, but also, let's see, soils. Every day, 0.001 milligram of pollutant is into the soils here. And then you can calculate the simulations and you can get the result, the new result. Here, already we have. So this is the new calculations. So maybe you can compare the result if we say that if there's the soil, how it changes. Or of course you can change any conditions. Or if you think the movement factors from compartment 1 to compartment 2 is more bigger, just like 0.03 or even 0.5, so you can calculate the result of the computer simulations. Just like this, and you can get the new error. Sorry. Yeah, like this. So anyway, so you can easily change the conditions, and by using these computer simulations, you can estimate the change of the concentration of each compartment, and you can simulate the exposures to human beings. Now, I just changed the parameters here, but also you can change the program itself. For example, if we want to increase the number of compartments, not only water, soils, and the vegetables, but also if you want to consider, for example, rice, or if you want to consider the air, you can also increase the compartments and change the program value. So these are how to use the computer simulation. I'm sorry, I don't have enough time to explain the detail, but I think how you can simulate the movement of pollutant in the environment, changing the conditions. So anyway, modeling is one of the art. So depending on the model you establish, also you can express those models by the mathematical equations. We call it the mathematical model. And then you can calculate those equations by the computer simulations, by numerical simulations. I just, it's almost over, so I'm sorry, but I just want you to know the one conditions of the weak point of the forward differentiations. Please give me several minutes. Now, as the delta t values, now 0.1 is used here. So the value is constantly positive for all times. But if you use, for example, delta value is, for example, maybe about 10 days, 10 days, how it changes? Sorry. In this case, it's okay. Let's say interesting. So 10 days is still okay. How about you? How about you? Let's see. Okay, let's see 1,000 days. Very difficult. 1,000 days. It becomes overflow, or maybe because of the some kind of errors. And so now, just only one step is calculated. So 10, 1,000 is big, too big. So anyway, so the weak point of the forward differentiation is the the total mass in one compartment must be positive. So now, for example, just 10, let's say 10 grams of fruit that is implicit in one compartment. And the flow rate input is 0.1 gram per day. And output is okay, 0.2 gram per day. In these cases. So if delta T is, for example, small enough, it is okay. If one day input is 0.1 and output is 0.2, so time is at the time delta T is 10 plus 0.1 minus 0.2, it is 9.9. So it's okay. But if you use delta T before 100, so after delta T values, okay, input is 10, 10 grams. Output is 20 grams. And the first initial finished value is 10 grams. So yeah, 100. Almost okay. It becomes 0. Still not negative, it's okay. But if we use the 200, it becomes 20 input and 40 output, and so minus 10 grams. And if you iterate these equations, maybe we call it divergence. So maybe the number becomes meaning, no mean. And maybe minus 10, next one is going to be 100, or next one is minus 20,000, or something. Well, just like these numbers. In this case, so minus 3.6 power 10 power 197, just in 100 iterations. So delta T must be small enough to keep the value of each component positive. So this is the weak point of the forward differentiation. So you need to use the small enough values at the T values. If it is okay, if you have the enough time and if you have the very good computers, so you can use the very small density values even for the 100 years simulations. But in sometimes it takes about 1 week for the calculations, even the very good computers. So in that case, we want to use the more big values with the key. But if you use the forward organizations, the key must be less than this condition. You fulfill this condition. Always keep the value in the code. At first, it is okay. But if initial value is almost zero, for example. So even in this case, in this case, at the first, next one is already the first step of the one. So in this case, the value is not so good. So usually, the problem is the also functions of the concentration of C1. So C1 times the cubic meter or something like this. So in that cases, I need to keep the positive values even if the place more negative values. But even in these cases, sometimes this condition occurs if you use the very big negative values. So anyway, if you find some of the result is becomes minus values, maybe delta t value is too big. So in that case, you need to change the delta t values to more smaller values to get the meaningful the result of the simulation. Sorry, I don't have enough time. So it's just experience of the computer simulations of the movement of fluid in the environment. So please try to use the macro or programs of Excel and how you can calculate the movement of fluid by the Excel. Okay. So this is the end of the module. Very question. Anyway, I want you to practice by yourself. So without you practice by yourself, maybe you cannot understand here. So if I had more time, maybe I can explain more detail, but sorry.
Okay, I will ask them to practice by himself. Ada pertanyaan? Ya. Dia sudah biasa.
Oke, boleh.
Oke, hari ini sesinya terakhir ya. Kita berikan sesuatu. Oke, minggu depan terus biasa ya. Kalau misalnya terus ujiannya mungkin ya kan tadi ada tabel di sini ya. Ya, saya pun mau coba.